Good morning, I'm here at Embedded World and joining me today is Bob from Digi International, who is the responsible for product marketing. So thank you very much for joining me today.
Thank you for having me, Paige.
You're welcome. And today we are going to be talking about cellular IoT and the Digi XBee Sensor Lab. But before we do that, could you just introduce yourself for us?
Sure. So my name is Bob Blumenscheid. I'm the product marketing manager for Digi International. We're a global company that focuses on IoT and connections and network devices. So here in the OEM business unit, we're responsible for our XBee wireless modules and then also Connect Core system on modules. But we'll be talking about XBee today.
Fantastic. So for those of us who aren't perhaps familiar, can you just tell us a little bit about cellular IoT?
Absolutely. So cellular IoT is a way to connect and collect data anywhere in the world over the cellular networks that have been deployed. So typically, cellular has been used for voice. And as you know, we've gone from 2G to 3G to 4G to 5G. But there's bands in the 4G range for IoT data. So it's low bandwidth, low data rate to collect data maybe once an hour, once a day. And so Digi has developed an XBee and really expanded our XBee product line to go to XBee 3 global cellular. So we really can deploy XBee everywhere now. Mm-hmm. So cellular IoT gives you the ability to reach anywhere there's a cellular network anywhere in the world and connect your devices without having to build a private infrastructure of your own gateways or your own Wi-Fi network or your own Ethernet network. You can leverage the existing cellular network to collect and maintain data.
Now, the use of cellular IoT is growing quite rapidly. So why is that, do you think?
Absolutely. It's in a category of low power, wide area. And it's the need to extend the IoT out into agriculture, mining, anywhere we can reach. So, and also the infrastructure is there now to do that. Mm-hmm. So the products are there, the hardware and software are there, and the network's there. So it's a great solution for certain use cases in IoT.
How do you see it sort of expanding and evolving in the near future?
Yeah, so we really see a lot of use cases for this, primarily asset tracking, because you can hook up cellular anywhere, track anything from a container to construction equipment to just about anything you need to attach it to. Then what we're doing here and what we'll be talking about in the sensor lab is smart sensors and a smart sensor deployment. And then the last one is remote management and control, and really being able to reach out and control a product, update a product in the field. So over the cellular network, if you need a software update, a feature update, a security update, you can enable that right over the XBee and the cellular network.
Fantastic. And I understand that recently you've expanded the Digi XBee 3 family with two new global cellular LTE smart modems. So can you tell us about those?
Absolutely. So we launched here at the show our new XBee 3 global cellular family. And it includes a module that covers both the LTE-M and NB-IoT networks. And that gives you the ability for low data rate, low throughput deployment in just about everywhere in the world. And those are newer technologies are very well suited for IoT. Then we have customers who want to pass a little bit more data out into their devices. And we've implemented a Cat 1 and even a Cat 4 that'll be part of the family. So we'll have a complete family, whatever the use case is for cellular IoT.
Fantastic. And you've also unveiled a whole host of other solutions and services here at Embedded World. Tell us a little bit more about the XBee Sensor Lab in particular.
Right. So to illustrate cellular IoT, we wanted to build a demonstration that was both educational and fun and illustrates the different use cases for cellular IoT. So essentially what we have in our booth are these boxes that are cellular IoT in a box. Everything you need for a cellular IoT deployment at the edge is right in this box. And what we have is a sensor mounted on top. And what we did, we worked with one of your suppliers, SparkFun, one of Digi-Key suppliers, who creates a line of sensors called Quick QWICC, that you can connect to just about anything. And we connected about 9 or 10 different sensors to our XBee development board, and we're talking to it in the XBee cellular. And the XBee cellular has a microcontroller in addition to the cellular modem. So we can collect the data, we can filter it, we can manage it, and we can send it out over the cellular network. So that's the server side at the edge. And you're all the way at the edge. Now we send it out over the cellular network. We come to a cloud, and then we can display that same data on a dashboard. So as you see, I have a noise sensor, and if it's down at the bottom here, bottom center. And so when I make a little noise, within a couple seconds, you'll see that reflected in the sensor. There, and it's gone up. It's gone from 48 to 74, and it's responding fairly quickly. So the cloud is in the United States. The probe, the sensor is right here in Nuremberg, and we're bringing data back into a local display. And typically cellular IoT, maybe once an hour, once a day, or an alert when something happens. Another one we have is a gyroscope, and it's a 3D accelerometer over here. So when I start maneuvering that around, within a minute here, we should see the display change. So then the accelerometer would show we were moving. So what's the use case for noise and gyroscope? Essentially, you can think about predictive maintenance in a remote machine. So more increased noise is typically an indication in a machine that a bearing is starting to fall apart, or something's falling apart, and you're detecting increased noise. You can take it back to your cloud. You can have an artificial intelligence model analyzing the noises and saying, okay, this machine is starting to degrade, and within 72 hours, it needs a service call.
Right.
So that way you're receiving an alert, you're tracking a whole fleet of devices, and your cloud is automatically scheduling service calls based on the problems that are happening. So gyroscope is much the same thing. You may have an EV charger out in the field, and it's working fine, and you might sense that it's suddenly moved sideways or fallen over because somebody has backed their car into it and it's fallen over. You get an alert back in your sensor, and you know somebody needs to go out and check that. We can even, over SMS, we could drive those messages to a phone, to a cell phone of the person who's responsible for it. He can call up a camera, take a look at it, see what happened.
Yeah.
So it really lends itself to a variety of use cases. The last one I have is a precision agriculture example, which is a moisture sensor. And again, another SparkFun sensor that's available. And we're now going to do precision ag on our plant here. And it's reading the soil moisture. And you see, I put that in, and that one actually jumped up very quickly. So if I take this out, you'll see it drop down to 0. And then if I put it back in, it jumps up very quickly again.
Yeah.
So soil moisture sensors are deployed in fields very closely, so they can water exactly where a farmer can water exactly where it needs it, rather than just irrigating the whole field.
Yeah.
And the irrigation arms that you see in big circles can be programmed based on the data to automatically provide just the right amount of water to the plant at the right time. And all that's accomplished with cellular IoT.
Yeah.
If the wheat farm in Manitoba is out of range of cellular, we're working on new technologies where we'll have LoRa or LoRaWAN connecting, which goes over a much wider range and even can reach satellites in low Earth orbit to collect information, pass it back, and do the same thing.
Fantastic. So what would you say then is the overall aim of the lab? Is it just to highlight the different applications?
It really is. It was to make people at the show see cellular IoT.
Yeah.
We didn't want to do a schematic or a diagram, but it's something you can pick up, you can experience how it works and really understand it. And I think a lot of people haven't really thought of cellular as an IoT technology.
No.
Is it VLAN, Wi-Fi, or Ethernet, or other things? but you can leverage the cellular network that's all around you right now to connect your devices and read them. So so there's been a lot of education going on as well.
Fantastic. So tell us about this little guy that you've got over here.
Yeah, so we have another demonstration, which is the XBee robot, or as we like to call it, XBot. And it's a educational robot from Parallax, another product available at Digi-Key. And they market into the STEM market, where they have workshops and kits, and it's Arduino based, and we enabled it with an XBee cellular. And what we wanted to show was the ability to even connect over SMS or text message and control this. So what I'm doing here is I'm sending the robot a command to move forward. The command is forward. And in just a short time, it goes out and it's moving forward. So you can control it, again, over the LTE-M cellular network. So it's more than just a radio control car. We mounted some sensors on that as well. And when you tell it sensors, I'm using sensors on this robot to say that it is 32.7 degrees percent humidity in here, 66 degrees, and the CO2 is very good at 171 parts per million. So the example is it's a robot that can go into hostile environments and see what's going on. It can, there's starting to be legislation in schools to monitor CO2 levels in schools. And here's a robot that could drive around the classrooms and measure CO2 and report it back, include logs. Not only can we display data, I'm just going to switch. We have the ability to store data and look at historic data as well.
Okay.
So you can see we're actually showing the data changes and graphs of all the sensors. So it's capture data, store data, and then to monitor things, and then use that data you've collected to create actionable insights. Whether you're routing trucks or deciding, open a window in a school or irrigate. That's really the goal of cellular IoT, is use that data to make things better, save money, make things more efficient, do things better.
Yeah. What a fantastic way to get everyone, involved and the application is fantastic.
Yeah, and we'll take these, we've created these demos. We want to create workshops, demonstrations. Everything will be downloadable. The software will be downloadable. The boxes will provide files for laser cutting and things. So we really want customers to have a way to proof of concept and prototype IoT and put out a system and get their hands on products they can hook up and use immediately within days to start developing a system, finding out what works for their own business, and then scale out into production. So all these demonstration pieces scale to production. They're not hobbyist or maker products. They're production products that can be accessed very easily.
Fantastic. Well, thank you very much for bringing them into the studio today. It's been a real pleasure, and thank you for your insights.
Okay, great. Thanks for having us, Paige.
Thank you very much.